Imagine this. A small village is hit by a huge storm. The power lines are down. Hospitals have no electricity. Schools are closed. Phones cannot be charged, and even clean drinking water becomes a problem. Now imagine a truck arrives carrying something about the size of a shipping container. People think it's just another cargo box. But inside that box is a tiny nuclear power plant. Within a few hours, the village has electricity again. Sounds like science fiction, right? Well, this is exactly what microreactor technology is trying to make possible. So what is a microreactor? A microreactor is a very small nuclear reactor. Think of it as a mini version of a large nuclear power plant. A normal nuclear power plant is massive. It can power millions of homes. A microreactor is much smaller. It can power a small town, a military base, a remote mine, an island, or even a research station in the Arctic. Think about your home. Instead of buying electricity from a huge power station hundreds of kilometers away, imagine having a small, safe power source nearby that can produce electricity for years without needing more fuel. That is the basic idea behind a microreactor. How does it work? Inside the reactor is a special nuclear fuel. When the atoms in this fuel split, they release heat. That heat is used to produce steam or hot gas. The steam spins a turbine. The turbine turns a generator. And the generator produces electricity. It's almost the same process as a large nuclear power plant, just much smaller. So why are people excited about microreactors? Because they have several advantages. First, they can be built in a factory and shipped to where they are needed. Second, they can provide electricity for many years without refueling. Third, they can work in places where solar panels don't get enough sunlight or where wind turbines cannot generate enough power. And unlike diesel generators, they don't need constant fuel deliveries. Are they safe? Modern microreactors are designed with advanced safety features. Many use passive cooling systems. That means even if the power goes out, the reactor can cool itself without pumps or human action. Engineers are designing them to reduce the risk of accidents compared with older reactor designs. Where could they be used? Imagine a hospital in a remote area, a mining site in the middle of a desert, a military base far from cities, or a small island that depends on expensive diesel fuel. A microreactor could provide reliable electricity day and night. Does this mean every house will have its own nuclear reactor? No. Microreactors are still much larger than anything you could keep at home. They are designed to supply power to communities, businesses, or important facilities, not individual houses. So, will microreactors replace all power plants? Probably not. But they could become an important part of our future energy system. Along with solar, wind, hydro, and other clean energy sources, microreactors could provide reliable electricity wherever it's needed. Sometimes, the biggest solutions don't have to be the biggest machines. Sometimes, a small reactor can make a very big difference.